All right, so the first thing you need to do for analysis of the data that Professor Schindler and I collected for you is to figure out what the spring force is, and more specifically the spring constant of the spring. So you might remember what we did is we measured, whoa, let me go back. So we measured the force required to stretch the spring by several distances. I think we did 4 data points, right? So we measured the force in both newtons and grams. Let's use newtons. And we measured the distance of stretch. Technically, it wasn't the distance of stretch. It was the total distance between the vertical shaft and the indicator rod. And this we did in centimeters, but let's just convert that to meters. So we got several data points, right? So we got force 1 and distance 1 and force 2 and distance 2 and so on, right? That was our data. So what you're going to need to do is you need to find the spring constant, that is the stiffness of the spring, and you can do that by plotting your data, force versus distance. And you're going to find that as you stretch it by different distances, the force is going to go up like this. And what you need to do then is you need to fit a straight line to your data. And that straight line, the slope of it is what's called the spring constant. So force equals K times X. So X would be your distance. So X equals the distance. F is your force. And K is called your spring constant, and it will be the slope of this plot. Okay, so K is spring constant, and by the way, it's going to be in newtons per meter because it's rise over run. And that is going to allow you, once you know the spring constant, it's going to allow you to figure out how big of a force is exerted by this spring when it's stretched to any distance. Okay, and you're going to be later on using that when we're spinning this mass around and the spring is stretching to different distances, and you want to find out how big that spring force is at that particular distance. Okay, so I'll stop there.